Hey y'all, this evening we're going to read Prenatal Testosterone in Mind, Amniotic Fluid Studies. You see that? Look at that little clump of cells, that's all that is. Little clump of cells. So, let's take a look at this book. Da-da-da. 2004. Oh, we're only going to read a couple of chapters. We're going to read chapter 1, learn about fetal testosterone, and then we're going to jump ahead a little bit. There we go. Endocrine, that is, hormonal systems, are involved in every aspect of pregnancy, including implantation, formation of the placenta, maternal adaptation, and embryonic and fetal development. In birth and in adaptation to life outside of the womb. Hormones have a range of functions involving reproduction, growth and development, maintenance of the internal environment, and the production, use, and storage of energy. Of greatest relevance to this book are the gonadal hormones, which are essential to the sexual differentiation of the fetus. This process includes sexual differentiation of the sex structures, as well as aspects of behavior and cognition. The gonadal hormones, or sex steroids, include androgens, that is, testosterone and dihydrotestosterone, estrogens, that is, estradiol, esterone, estriol, and progesterones, that is, progesterone. Progesterone is synthesized from cholesterol, and progesterone itself can subsequently be converted to testosterone. The testosterone is a precursor to estradiol and to dihydrotestosterone. Figure 1 of 1 illustrates the chemical structures of several major gonadal hormones. Elftor, sun. Four endocrine glands are capable of synthesizing sex hormones: the adrenals, the testes, the ovaries, and the placenta. The synthesis is the same in all these systems, but the end product of the synthesis depends on the target tissue. For example, the testes secrete testosterone, but the placenta uses it to make estradiol. The process by which testosterone is converted to estradiol is called aromatization. Although estrogen is usually considered to be the female hormone and testosterone the male hormone, both hormones are present in both sexes. The sexes differ in the quantity of each hormone present and in the number of receptors for them. It is not only the availability of a hormone, but also the sensitivity of the target tissue that determines the hormone's biological activity. Androgens have a number of functions in humans. These include control of gonadotrophin production in the brain, initiation and maintenance of spermatogenesis, promotion of sexual maturity at puberty, control of sex drive, control of sexually dimorphic behavior patterns, and formation of the male phenotype during the sexual differentiation of the fetus. In addition to its involvement in sexual differentiation of the reproductive structures, known as its androgenic effects, testosterone is the major hormone responsible for sexual differentiation of such non-reproductive tissues as bone, muscle, kidney, and liver. These effects are called anabolic. Estrogens are involved in the development of female sexual secondary characteristics, development of the breasts, and prevention of bone mineral loss. They have major differentiating effects on the reproductive tract, on the distribution of fat, and on certain bones, including the pelvis, but only minor effects on other organs. Additionally, there is evidence that estrogens have a neuroprotective role during aging. Estrogens are important in the maintenance of pregnancy. For example, they are involved in the support of placental progesterone synthesis, And synthesis means creation. When your body synthesizes a thing, it's created from the body itself. In the increase and maintenance of maternal blood volume, and in the promotion of uterine growth. There is also some evidence that estrogen has a role of implantation of the fertilized egg. Estrogens can have masculinizing as well as feminizing effects on development. By week 3 or 4 of gestation, the placenta is responsible for nearly all estrogen production in pregnancy. Some estrogen is produced by the fetal adrenal gland, which is active from around week 8. The fetal ovary produces little or no estrogen early in pregnancy. No ovarian estrogen synthesis can be detected until late in fetal life. Most of the estrogen is secreted into the maternal blood, but levels are also high in the fetus and in the amniotic fluid. The role of these high estrogen levels in the fetus is not yet clear. That is, as of 2004. The most abundant estrogen is estriol, which is unique to pregnancy. It is mostly present in an inert form, so the fetus is protected from its potent effects. The mother has a high capacity for rendering estrogen inactive, and so does not experience detrimental effects due to the high estrogen production by the placenta. Men normally produce around 100 times more testosterone than estradiol. Most of the estrogen is made from androgens, but the testes also secrete a small amount. Normally insignificant, this can become abnormal in certain medical conditions. Serum concentrations of estradiol are low in males, but they can be higher in semen than in the serum of females. Male reproductive tissues are known to express estrogen receptors, and there is evidence for a physiological role for estradiol in male reproductive function related to the concentration of semen. Progestins can be androgenic or anti-androgenic in their effects, depending on their chemical basis. Their effects are predictable based on their chemical nature. For example, male typical behaviors have been observed in females exposed prenatally to androgenic progesterones. Progesterone is an anti-androgenic or progestational progestin. Progesterone has an essential role in pregnancy maintenance, affecting uterine musculature and inhibiting maternal immune responses to fetal cells. Another important group of hormones is the gonadotrophins, including follicle-stimulating hormone and luteinizing hormone. In the future, this is FSH and LH. Produced and released by the pituitary gland, these mediate the control of gonad function in both sexes. In males, FSH and LH are released in a constant, sustained manner, and females released in cyclic with a pre-ovulatory surge that leads to ovulation. Alpha-fetoprotein, AFP, not a steroid hormone, merits discussion at the point because of its potential role in regulating the levels of steroid hormones. It is a globulin produced by the fetal liver and yolk sac during the first and second trimesters of pregnancy, from as early as week 4, and it is often measured during pregnancy. Measurement of AFP in amniotic fluid is a reliable indicator of neural tube defects between weeks 15 and 22. In such cases, maternal AFP levels tend to be high as AFP leaks from the damaged fetus. In chromosomal disorders, low maternal serum levels could result from impaired fetal kidney function and impaired membrane or placental passage of AFP rather than reduced fetal production. AFP can be detected in the fetal brain after 12 weeks, with a peak value in week 20. Levels decline rapidly after week 24, after which AFP is absent. High levels are said to correspond to the period when critical hypothalamic Hypothalamic. Got it. High levels are said to correspond to the period when critical hypothalamic differentiation is reported to occur in humans. Say that 3 times fast. In placental mammals, the fetus is continually exposed to high levels of estrogens from the placenta and the mother. The protective mechanism from these high levels of hormones is well established in rodents. AFP binds to estrogen, but not to testosterone. However, AFP does not bind to estrogen in humans. The mechanism by which the human fetus is protected from high levels of estrogens is not fully established. The fetal hormone environment is dependent on a functioning placenta that regulates the exchange of molecules between the fetus and the mother. This means that the fetal environment is largely independent of maternal hormones because the placenta is impermeable to most hormones. The placenta synthesizes estrogens, progesterone, polypeptide hormones, neuropeptides, and growth factors. The placenta has a very strong aromatizing enzyme system, and androgens tend to get converted to estrogen by it. This means that very little androgen is transmitted by the placenta. Okay, this is where it gets really interesting, y'all. Becoming male or staying female. Sexual differentiation of the fetus. Gonadal hormones are responsible for differentiation of the male and female phenotypes in the developing human fetus. Although direct genetic influences on sexual differentiation of the brain are increasingly recognized, there are 5 major stages in normal sexual development. The genetic sex is determined at the moment of conception by the presence of an X, that is female, or a Y, that is male, chromosome in the fertilizing sperm cell. Okay, so you have probably heard this before. Just to be clear, the sex is determined by the sperm cell. The karyotype of the normal female is 46XX. That of the normal male is 46XY. And that is 46 chromosomes. Each is made up of 44 autosomes and 2 sex chromosomes. The male can be described as heterogametic, the female as homogametic. There are very few differences between the genes of males and females, except for the Y chromosome in the male. The genetic sex determines whether testes or ovaries develop. Up until week 6, genetically male and genetically female fetuses are undifferentiated. That is, there is no difference between them with respect to their reproductive structures. During week 6, I'm inclined to pronounce that as sorry. During week 6, the Siri gene on the Y chromosome initiates testicular differentiation in the male. This is thought to be the major function of the Y chromosome. The Leydig cells of the testes are capable of synthesizing testosterone by the end of week 8. Further development of the Leydig cells means that testosterone secretion is high between weeks 10 and 20. Fetal synthesis of testosterone is probably controlled by HCG, that is human chorionic gonadotrophin, and LH from the fetal pituitary. In addition, males are exposed to fetal testosterone from the fetal adrenals. In the female, differentiation of the ovaries begins around week 7. The female ovary may produce a small amount of estrogen. The female fetus is also exposed to low levels of androgens. A small proportion may come from the fetal adrenals, and some come from the maternal adrenals, ovaries, and fat. The secretions of the gonads thus formed determine the phenotypic sex. So phenotype, for those of you who don't know, is the way a person appears. If the male sex hormones and the appropriate receptors are present, the male phenotype will develop. If sufficient male sex hormones or functioning receptors are not present, the female phenotype will develop. The internal genitalia of both sexes are derived from the Wolffian and Mullerian ducts, which coexist in the undifferentiated developing embryo. In the male, between weeks 8 and 14, the Wolffian ducts, stimulated by testosterone, develop into the male internal structures. The Mullerian ducts regress, thus preventing the formation of female internal structures. Regression of the Mullerian ducts is caused by anti-Mullerian hormone or Mullerian regression factor, secreted by the Sertoli cells of the testes. The formation of the male external genitalia is stimulated by dihydrotestosterone, which is formed from testosterone by 5A reductase. In the female, the absence of testosterone causes the Wolffian ducts to atrophy. The absence of anti-Mullerian hormone allows the Mullerian ducts to become the female internal structures. Similarly, the absence of male sex hormones allows female external genitalia to develop rather than male structures. So, let us go over that real quick. When you a little embryo, you have two ducts, the Mullerian and the Wolffian. If you have a Y chromosome, the Y chromosome is going to transform your Wolffian duct. That testosterone will turn your Wolffian duct into male genitalia. And if you do not have a Y chromosome, then it should atrophy as your estrogen transforms your Mullerian duct into female genitalia. I feel like everybody ought to know this, right? I mean, did you learn this in school? Not me, but then again, I'm a dropout. Neuronal sex, which refers to male type or female type gonadotrophin secretion, sexual orientation, and gender role behavior, and gender identity, are shaped to a large extent by prenatal factors. Let us read this again, brothers and sisters. Neuronal sex, which refers to male type or female type gonadotrophin secretion, sexual orientation and gender role behavior, and gender identity are shaped to a large extent by prenatal factors. Do you understand? Prenatal factors means what is going on in a woman's amniotic fluid, which is feeding into the fetus and changing its body and its brain. These things control how a child is formed after it's born, to a very large extent. In summary, masculinization requires the action of testicular hormones. The default mammalian sex is female, and in the absence of very high levels of male sex hormones, female structures will develop. It has been assumed that no special hormonal environment is required for the formation of the female phenotype. That traditional model is now being replaced by a more complex one which recognizes that small amounts of ovarian hormones may be required for active feminization of the female brain. Still, many stages must be completed successfully in the male phenotype, if the male phenotype is to develop, and these stages rely to a large extent on the existence of the right hormonal environment. This implies that there are a number of stages at which the normal development of the male could be disrupted. Not all animals have female as the default sex. In birds, for example, the default homogametic sex is male, and differentiation of the female depends on exposure to ovarian hormones. In mammals, fetuses are exposed to high levels of female hormones from the mother, so it is adaptive for the default sex to be female. In egg-laying species, this does not apply, so having one sex as the default sex over the other does not necessarily confer the same advantages as in mammals. It is interesting to note that feminization of the brain in mammals by ovarian estrogen is thought to occur at a later period than masculinization. In female rats, this may extend from the late neonatal to the pubertal period and perhaps even into adulthood. Ooh, okay, hold on. I gotta adjust. Sorry, cat. Where we is. Head into adulthood. I'm just reading up here. Ooh, okay, there we go. This would mean that ovarian estrogen mediated feminization takes place after the individual is free from the maternal hormone environment of the womb. Organizational versus activational effects and sensitive periods. Okay, so this big highlighter on this. This is where it gets even more interesting. Sex hormones have two different types of effect on tissue: organizational and activational. Organizational effects are permanent and happen early in development, usually during a sensitive period. Activational effects happen later in development and are superimposed on the early organizational effects. The later hormonal actions are necessary if the tissue or organ in question is to perform its function. For example, the tissues of the genetic male are organized prenatally for male adult reproductive behavior. However, the male will not display such behavior unless adequate sex hormones are produced at puberty. Although the dichotomy between organizational and activational effects is useful for understanding hormonal effects, it cannot always be rigidly applied. The yes. When studying the organizational effects of hormones on the developing fetus, it is important to remember that later activational effects may be essential to the function in question. For estrogen, the distinction is particularly problematic, as estrogen appears to exert organizational effects for a very long period of time. Both adult and fetal studies can be subject to the same criticism. The relationship between the time of measurement and the sensitive period for development is unknown. Sensitive or critical periods are hypothetical windows of time in which a tissue can be modified. Environmental disruptions during development can have devastating effects. Again, environmental disruptions during development can have devastating effects. A substance that causes damage during a critical period, I believe, should that say during? A substance that causes damage during a critical period may have no effect at all when development is complete. It is therefore adaptive to restrict development to specific limited time periods. This means, for example, that circulating sex hormones necessary for adult sexual functioning do not cause unwanted alterations to tissues, even though the same hormones might have been essential to development of those tissues. Different behaviors can have different sensitive periods for development. For example, androgen exposure early or late in gestation has differential effects on male typical juvenile behaviors in the female rhesus macaque. Look at me getting all lost. Gonna lose my audience. After the prenatal surge in testosterone production, there are two further testosterone surges in the human male. These occur neonatally and at puberty. Although the function of the neonatal surge is not fully understood in humans, it is likely to be related to the preparation of tissue for subsequent androgen-mediated growth. In monkeys, disruption of the neonatal surge is known to lead to disrupted testicular function at puberty. As males may experience a testosterone surge at this time and females do not experience such a surge, the same amount of subsequent testosterone exposure will have very different effects on each sex. Females experience a postnatal surge in estradiol production, which is thought to come from the ovaries. Levels remain high for the first year of life, peaking around month 3 or 4. Median levels are equivalent to those in the second stage of puberty. The postnatal surges in both sexes are stimulated by surges in gonadotrophin levels. Sexual differentiation is not complete until puberty, when secondary sexual characteristics develop and fertility is attained. The development of the gonads can be viewed as a continuum from the fetal stage to puberty, with reproduction as the ultimate goal. The factors that influence testosterone levels, both prenatally and postnatally, include stress, alcohol use, smoking, and the spacing of births. All right, another I gotta put my highlighter on this one again. The factors that influence testosterone levels, both prenatally and postnatally, include stress, alcohol, smoking, and the spacing of births. Prenatal stress in the male rats demasculinizes and feminizes adult sexual behavior, and testosterone levels in newborn rats are reduced in stressed animals relative to non-stressed controls. I said prenatal stress in male rats demasculinizes and feminizes adult sexual behavior, and testosterone levels in newborn rats are reduced in stressed animals relative to non-stressed controls. Human homosexual males report more stressors, such as bereavement, that is being heartbroken, during their mother's pregnancy than controls. In females, there is some evidence that prenatal stress is associated with male typical gender role and sexual behavior. Testosterone and estradiol are also significantly decreased in alcohol users. Serum testosterone levels are positively correlated to smoking in mothers during pregnancy and also in their adult daughters. Daughters smoking during adolescence is influenced by mothers smoking during pregnancy and by maternal testosterone levels during pregnancy. In addition, maternal testosterone during pregnancy influences daughters' testosterone level. So this could be one mechanism whereby testosterone levels are transmitted from one generation to the next. You see, kids, this here is called a generational curse. You know, you get all stressed out, you start doing things to your body, and then you go have a child, and they're going to inherit your stress, and it's going to corrupt them before they even grow up. Hormone levels during a pregnancy are also influenced by how recently the mother has had a child. Firstborns of both sexes have higher estrogen and progesterone levels, and male firstborns have higher testosterone than laterborns when these are measured in umbilical cord blood. This is not due to the maternal age, length of labor, or birth weight. Close spacing of childbirths, that is less than 4 years, results in lower than normal hormone levels. The reduction in hormone levels is greater when the fetuses are male. After 4 years, levels are at firstborn levels or higher. Well, that was interesting, wasn't it? Learned a lot there. I want to read a little bit more to you. Where's my bookmark? I had a bookmark in here. Did my bookmark come out? All right, well, bear with me for a bit while I find what I wanted to read to you. I mean, yeah, think about what I just read, though. If you're drinking and smoking, you're hurting your future children. And if you are pregnant and you have high stress, your child is being hurt. It's going to suffer for that. And that's what's happened to us. That is what has happened to our children. What happened to the children? What happened to us? Well, that's it. I just told you. And now you know. But Julian, that book is from 2004. Okay, well, go read a newer book on it. Tell me what it says. Testosterone and autism. Any links? Well, I'm glad you asked. The first piece of evidence that links autism to maleness is the striking ratio of males to females among individuals with the condition. The sex ratio of males to females reported in the literature ranges from approximately 2-to-1 to 4-to-1. And approximately 9 times as many males as females are diagnosed with Asperger's syndrome, which can be viewed as a milder form of autism. The exact ratio depends somewhere on the inclusion criteria adopted, such as excluding severely retarded individuals or using a broad definition of autism. A second link to maleness comes from the cognitive studies of autism. Experimental findings have led to the suggestion that autism is an extreme form of the male brain. Have you ever heard of the term hypermasculinization of the brain, referring to autism? These findings include reports that individuals with autism are superior to controls on tasks that normally give rise to male superiority, and impaired on tasks that normally give rise to female superiority. One candidate mechanism for this association of autism and being male is the action of prenatal male sex hormones. This idea that autism might be linked to high levels of prenatal testosterone was also a part of the Geschwind hypothesis. Fetal testosterone was hypothesized to cause hemispheric abnormalities underlying the cognitive characteristics of autism. Other research, which has looked more directly at hormones and autism, has further highlighted a possible link between autism and testosterone. Findings include observations of hypermasculinization and precocious puberty in clinical patients with autism. Additionally, a link between aggression in autism and abnormally high androgen levels has been observed. Androgen being the male hormone. One study of 39 pre-pubertal and post-pubertal males with autism reported that their plasma testosterone levels did not differ significantly from those of 12 mentally handicapped and 21 unaffected controls. This finding does not contradict the theory that sex hormones are associated with autism, as the study looked at postnatal hormone levels rather than prenatal levels, which would be more relevant to the shaping of brain development. There are no studies to date examining the relationship, if any, between FT levels, fetal testosterone, I suppose, and autism spectrum conditions. Insel, O'Brien, and Leckman argue that 3 observations about autism are consistent with the idea that relevant neurobiological events take place early in the development of the central nervous system and involve a cascade of complex gene-environment interactions. First, autism is, by definition, a developmental syndrome, and its onset invariably occurs before the age of 3 years. Second, abnormalities in... Do you hear that, by the way? Autism... The onset of autism invariably occurs before the age of 3 years. So no, you ain't getting autism while you're a teenager and all that. Second, abnormalities in social interests can be observed even in the first few months of life. Third, the existence of a sex bias is consistent with other neurodevelopmental disorders, and this lends further support to the role of the intrauterine environment. However, when considering the potential role of fetal testosterone in autism, it is important to keep in mind that many biological factors, both hormones and neurotransmitters, have been implicated in the condition. 2 of the most prominent are oxytocin and serotonin. Gilbert and Coleman summarize a number of biochemical findings associated with autism. In addition to hyperserotonemia. These include studies of catecholamine metabolism, cyclic AMP amino acids, peptides, minerals, and ions, including evidence of increased lead levels in individuals with autism. Gilberg and Coleman also review some inconclusive evidence of immunological and thyroid dysfunction in autism. It could be that these different biological observations in patients with autism are all related in some way. For example, testosterone has been reported to affect the pattern of serotonin innervation in the hypothalamus, and sex hormones have been observed to affect central serotonin metabolism. Testosterone was linked to immune functioning by Geschwind, who also suggested that the Y chromosome in the male affected the thyroid. It could be useful to look for links between the different theories, or parts of them, because they could all be relevant to explaining the biological causes of autism. Well, I think that's enough for now. This is the book. It's from 2004. Maybe go read a newer one. But we learned a lot from this. So, if you all stressed out while you're pregnant, your baby gonna suffer. Men, if you have a lady who's pregnant, you better be patient with that woman. You better forgive her for being however she being. And don't be mad at her, because your child's gonna suffer. If you let that woman suffer, your child's gonna suffer. If you're with a woman who is smoking and drinking and you want to have a baby with her, y'all gotta change. You gotta overcome that curse. You gotta do it well before you have the baby, well before you get her pregnant. Ladies, well before you get pregnant. Stress is hurting you. It's going to hurt your children. The only way to break the curse is to find peace. Forgive yourself and forgive the people who hurt you. Have peace. Have peace, my friends. My brothers and sisters, have peace. Because if you get stressed out, everyone suffers. Especially your baby. Your baby might wind up autistic. Your baby might wind up intersex, which I didn't touch on in there. So much can go wrong. Stop putting stuff on your body that don't belong there. You got to think, my brothers and sisters. Thank you for watching. Meditate on these things. Watch it again if you have to. Pause it and scroll through and read it yourself. Go buy this book. This information can save us all. I mean, how long has it been? 11, 21 years since this book was published. We act like we don't know where autism comes from. We do. We act like we don't know why men are weak. We do. We act like we don't know what's going on in the world. Okay, maybe the people who are too busy smoking and drinking and jacking off and all that, maybe they don't know. But the people who aren't doing that, who are looking at the world and saying, what's going on? And who are seeking information because they want to understand it, that they may overcome it, that they may help others overcome it. I mean, the information's there. Finally, it's not enough to just read. You need Jesus Christ, which is the unity of all people, sacrificing ourselves one for the other. I love you, brothers and sisters. Have a good one.